Okay, so it's 10 past 12, so we should be starting. Hopefully all people that wanted to join have already joined. My name is Spiros Nikolopoulos. I'm a senior researcher in the Center of Research and Technology, Hellas, in the Information Technologies Institute. Again, as you can see my screen now in full mode. I've been the coordinator of the EU-funded project PrismArch, which deals about virtual reality-aided design, blending cross-disciplinary aspects of architecture in a multi-simulation environment. So essentially, we wanted to see how the VR technologies can help the field of architecture and the procedures that are taking place there. And this webinar is about this. So how does multi-simulation results can be visualized in a VR-aided design environment? Architecture has a lot to do with decisions and visualizations and simulations coming from different disciplines, either as a lead architect or as a structural engineer or a mechanical and plumbing engineer. And all this needs to be evaluated together. So the idea is that we build an interface into VR, an immersed interface, an immersed experience, where the simulation results can be easily captured by, let's say, the stakeholders so as to make better decisions. So in this webinar, I will be mostly explaining you a little bit about the theory. I mean, what are the motivation and what are the technological decisions that we had to do, the challenges that we have to face. And then I will quickly track you through the actual interfaces that we have developed, the VR experience, the immersed experience that has been made available to our end users, to architecture, structural and map engineers for pushing forward their day-to-day work. So a little bit about the motivation, battle-informed decisions. As I have said that usually when you design at this level, there is insufficient perception of the impact of certain choices, leading to suboptimal decisions. So to put it very simplistically, you want to put a wall somewhere and a window somewhere, you don't really know how this will affect the actual construct. And this is already an issue for the people that need to design and only use their imagination for understanding what is the impact of their designs or choices. The second thing was the motivation was this idea of parallel worlds. Although we discuss about architectural projects and large constructs, we need to understand that there are many different disciplines involved in this process. So, as I said, it's the architects that are, let's say, making the designs, but they also need input from the structural engineers so as to be able to see how they can support what they envision as a construct, and map engineers and mechanical engineers, but also engineers that have to do with audio, lighting, and so on. So all these need to come together in order to be able to and collaborate in order to complete a complicated work, because we basically talk about complicated constructs. And there is a tendency that these worlds go in parallel, so there is no much exchange between these worlds, and this is already an issue. And the final motivation was about immersiveness. We all know, I guess you're all here because you want to see how the VR technologies can help in different domains and can help in, let's say, different processes. So we had to work, we had to see how much the VR technologies can actually help us tackle the above. And the challenges that directly derives from the motivation. So we talk about a singular design space. As you will see later, each discipline tends to work in their own space, using their own tools, using, let's say, their own particularities, and having a singular design space where they all can reflect, where they all can put in their designs and their opinions is, let's say, a great challenge. And also in this space, we need to make sure that all materials necessary for day-to-day collaboration are accessible. So apart from, because we talk about architecture, apart from the 3D models and let's say other 3D constructs that your mind may go to, we also need to make sure that more, let's say, simplified material like PDFs or images and so on that they use in their day-to-day work should also be accessible. And this brings us to the next challenge, to interconnect with existing software tools. You will hear a lot about it. As you probably know, this discipline uses many different software tools. You have probably heard of Revit, of Rhino, of AutoCAD, or SAP. I mean, people in the field should already know about this. Each piece of software specializes in different things. And in order to have a complete picture, you probably need input from all these types of software. So it was one of the fundamental challenges that we have to face, to build something that can interconnect with these existing tools. Because otherwise it is very, very difficult to suggest something that people will put into their everyday work, unless it smoothly interconnects with what they already know to use. And another interesting thing is that may not be that of a technical interest, but it is from the, let's say, from the business perspective. In the domain of architecture, it has started to become very, very important, this golden thread principle, which is essentially a requirement, a legal requirement, at least in the UK, that you should be able to trace back all decisions. So you should be able to identify when a certain decision is made, by whom, and what, who is liable, and so on. So everything needs to be recorded or logged, in a sense, to be able to trace back. And this is useful because when something goes wrong, you need to be able to identify why it went wrong, and also, let's say, put the necessary liability. When we initially, let's say, discussing about the proposal, we have looked into existing solutions. This is a non-exhaustive overview. You can find in outside the Archeo and SCAP, Fuso, and Gravity Sketch. They all provide some kind of some of the functionalities that we envision in our project. Also, there has been also major efforts by, let's say, the major players in the field, like NVIDIA and Holodesk, and Twinmotion by Unreal itself. All of them do provide some kind of immersiveness, so that can also, sometimes they can also link with existing software tools. PrismArch was there to put this to cover more in terms of being able to support different versions, being able to log everything, being able to, apart from a design tool, be also a knowledge management tool that can help people do their work, and also unite them, so break these silos of interdisciplinarity. And this is the very high level concept of PrismArch. So essentially, three different disciplines were engaged: architects, structural engineers, and mechanical and plumbing engineers. They do all use different kind of software. Our goal was to build something that will be in VR, but also will be able to interconnect with these tools, and then end up with a collaborative VR space where all of them can work together. And for this purpose, we have relied on Unreal for immersiveness. It's one of the two engines that can support VR technologies. Speckle has been very fundamental in our developments. I will talk more about Speckle. It's an open source software that has been put out there to serve exactly this purpose, to facilitate the interoperability between different software tools in the domain of AC, of architecture, engineering, constructions. And more for that, we do have some research aspects that have to do with artificial intelligence for designer modeling. So we want to see how more advanced technologies for artificial intelligence can help during the design process, by semi-automating some suggestions or semi-automating some design choices. And another important aspect, host of cognitive analysis for usability guidelines. I mean, you can understand that when you take a procedure into the VR space, you actually overwhelm the user with too much information that you are not always sure whether he or she will be able to digest. So it's important that you make sure that you don't overwhelm the user, and it only has access and view to the information that is necessary to proceed. And this is a little bit of an overview of what we have accomplished, and if we can take it in three major pillars. First, we have to ensure the interconnection between all different software types, and be able to connect Unreal with Rhino, with Revit, and SAP. This has been one major undertaking that we have done. The second has been to build this collaboration space. So how do we have co-presence in an environment of users that they can bring their material, images, PDFs, 3D models, bring also the models that they are been working on for the construction, interact with them in novel ways and insightful ways, and discuss about it and interconnect. And then with the experience space. So this is the added value of when you go in VR. As I said in the beginning, the idea was that to facilitate people have a direct understanding of what their design zones is. So to put it in a high level, they discussed here on this table, they do some design choices, but they put things, they add things, let's say, into their current project, and they can immediately go into what we call a physical scale or an one-to-one scale and see the impact of their choices. So main accomplishments that I will take you through this presentation is the interconnection architecture. What has been the architecture that we have achieved to achieve this we have adopted to achieve this interconnection between the different software tools. The Speckle Connectors, and I will tell you a little bit about what it entails, so as to be able to support a certain piece of software. And we'll talk a little bit about the semantics and digital tags, and this mostly relates to the fact that what we have been doing, apart from, let's say, a visualization and design tool, should also be a knowledge management tool that we can easily search things and interrogate things, and being able to retrieve and inform about it. So it was no more than a simple model viewer. It should be something like a knowledge management system. And I will close up with the interfaces for intuitive interaction. And I will take you through a number of screenshots that can give you a better idea of how the current prototype looks like and what it can support. So about the interconnection architecture, again, we have started by looking at the state of the art and see what was the available options there. So for exchanging information between different software packages, you already have this option of file transfer. That is not the best, but although it sees the practice now in many cases, it's by far the most straightforward approach. There has been also this streaming approach based through the live link by Unreal Engine. There has been a development by Unreal Engine a couple of years ago that allowed to somehow lively link with an existing software like Rhino. So changes made in Unreal can be visible in Rhino and vice versa. But nevertheless, this is only on a streaming level. So nothing goes into a central database and nothing is being recorded. And the other option has been the central database connections, to have a common format in a central database where things can actually, all different software tools and let's say all the users can exchange information in a collaborative mode asynchronously. And there was the option of Speckle, which was the one adopted in our case, and also from Omniverse by NVIDIA, which is a general purpose solution. Also in this direction. This is a little bit of an understanding of all the different users and all the different, let's say, software tools that may be involved in as the project evolves, from the conceptualization to matureness and final refinements. So you can see there are many different people that are being involved in different spans of the project and using different software tools. So you can start from Blender to draft some 3D models, Rhino 3Ds for being able to do some more architecture-oriented designs, SAP for structural engineering, Revit for map engineering, and so on. And it was important to understand how this would work. And at that point, we have identified the need for asynchronous collaboration, but also for some synchronous presentation and annotation. As we have, let's say, progressed in the project, it became evident that we cannot support both of them, and it was more realistic to rely on asynchronous collaboration and stick to that. So the idea that we have adopted is something that is very more close to how GitHub works. I can see this may be familiar for those working in GitHub. This may be familiar to you. Whereas there is a main branch, there is some branches that are being derived from the main branch that at some point they submit back to the main branch and merge changes. So this has been essentially the architectural choice that we have done, and in order to do this, we have relied on Speckle, which is exactly this. Exactly does this promise to be a GitHub for the AEC domain, for the AEC discipline. It relies on asynchronous collaboration, and what Speckle does, I mean, because you understand that this issue of interoperability, of, let's say, low interoperability between different tools, it's because of they use different format types. So what Speckle does was to define a common denominator among all these formats, so as to be able to easily exchange between them. And also define a very, very basic schema when all of them should comply with, so as to be able to exchange content without a problem. And all this, after defining this problem, the next development thing is to develop the Speckle connectors, that I will come back to this later, that will allow each and every software tool, as you can see, SAP, Rhino, Revit, and so on, to have a plugin, a connector that will allow them to exchange information with Speckle. And of course, it was part of PrismArch, and it was, let's say, our own undertaking to do a similar connector for Unreal, to do a similar connector that will allow to deal things in VR. So by using this architecture, we have essentially addressed the challenge of going in virtual reality, going in immersive space, but making sure that we don't lose connection with what users are already using in terms of their day-to-day work. So moving on to Speckle connectors, give you a little bit more idea of what this entails. As we said, Speckle is the GitHub of collaborating on the 3D design. It essentially relies on a PostgreSQL database and uses JSON storage format. It has a number of web management interfaces, and it's, let's say, its core rely on these interconnectors, on connectors. So, as I said, they have defined a fundamental schema of how to do with geometries, how to do with textures, and a number of other stuff that are important for architecture. And then they ensure that this will be interoperable with the existing tools by the existing of a connector. So essentially, to give it in very small terms, you set up the Speckle manager in your device, in your machine, and then you need to install the connector for each and every of the tools that you want to use. And afterwards, you can commit things from your own software to Speckle manager and see them online. But you can also do some actions here online that you can commit back to the software tools. To give you a little bit of more of understanding of how this works, so this is for CAD interconnection. Usually it's, let's say, most people they rely on Rhino 3D to receive new designs for editing. And the cycle goes like this. So to push things to Speckle database and receive from Speckle database, and then you can also, since they're in Speckle, they can also be viewed in the Unreal environment, and then push them back to Speckle after doing the changes in the Unreal environment, in the VR environment, so they can also go back to Rhino to do more elaborated work there, or more detailed work. And this has been the case for many different software tools. when we started, things were not mature enough, so we had to contribute a lot into the Speckle community. Some things were there, like going from Rhino to Speckle and vice versa, but the connector that had to do with connecting Speckle with Unreal was not there, and has been one of our important undertakings to contribute in the development of this connector. Again, this is the case from Beam. I won't repeat myself. The idea is from Revit software, push to Speckle, receive things in Unreal environment, and then push them back to the Speckle database so as to become again available for being editable in Revit. Again, here our main contribution was in developing the connector for Unreal to be able to handle all the imports coming from Revit. And you can understand that this is not straightforward, because apart from the geometries itself, there is a number of metadata that are associated with its object. So this should be handled in some sense also by the connectors. So we should be able to map all the, say, metadata schema that is used by Revit to the metadata schema that is used by Speckle, and be sure that in your Unreal connector, you are able to read that schema and use that metadata. And finally, again, this is the CAE interconnection. So for SAP 2000, another piece of software that is being used by the structural engineer. Again, the cycle is the same. The only difference here was that apart from the Unreal connector that we have developed, this was not elaborated when we initially started our project and started working on this. So our consortium had also to work on the connector from SAP to Speckle. So that's to give you an idea of the connectors and what is, let's say, the underlying software tools, the underlying technological modules that support the interoperability. The next accomplishment had to do with the semantics and digital tags. As I mentioned, PrismArch was more than a model viewer; it should be a knowledge management system. So, and Speckle was not entirely designed for this. So, Speckle was designed to be like the GitHub for exchanging models and being able to use branches and so on. But we had to build a layer of knowledge on top of this so as to be able to support complex queries with respect to what had happened to the object, or give me all the project versions that are associated with this object, or who was the user that has changed the version of an object or so. For this, we have relied on semantic technologies, and starting from the Speckle database and the GraphQL interface that it inherently supports, we have gone into a semantic representation and storage REST API. So based on an ontology that relies on bin information modeling, we have done this knowledge base, a knowledge layer that sits on top of Speckle, and it incorporates all the information that is already in Speckle, but it offers a much more powerful API for retrieving information. Apart from the GraphQL query API that offers by Speckle. So this is let's say, a glimpse of the ontology, a PrismArch ontology, and the main class hierarchy. And here is an example of semantic representation, example of object with tags and signatures. And the idea is that based on this overlay of this additional knowledge layer, we should be able to support queries like this. So access all commits where an object is found, or access all commits where a mess is found, or detect all objects that contain specific tags. Tags can be something that characterizes a certain object, like a chair, that offers certain aids and so on, taking into consideration the category and value. And of course, there are much more complicated things that we have to deal with, like the object signature, because when you go from version to version, or you are being from project to project, you need somehow and something that uniquely identifies an object, that you should be able to retrieve all the actions and all the information that has taken place with respect to that. And on top of this, another interesting undertaking has been this graph-based IDQS query tool. As you remember, as I said in the beginning, going from 2D to 3D, it's not, let's say, always straightforward, or it's not at all straightforward. When you overwhelm people with information, they will probably get lost. So you need a different paradigm of interacting with information. And so you need a different way to query stuff. And this graph-based tool has been there to support us in being able to retrieve information and interact with it, interrogate it in the 3D space by actually traversing the graph. This has been something that we have been trying on, and we're currently in its development, and we can see how intuitive this could be. And finally, I'm doing the last part of my presentation that has to do with the interface. That should be a little bit more fun for you and more easy to handle. Just to give a quick overview of what we can support. So there is two modes, a desktop mode and a VR mode. So you can do this in both ways, and a number of headsets that we have been supporting, like the Reverb and Oculus Quest. And there's some very, very directions that we have taken into our interface. So we should be able to have a user account system where users log in and based on their privileges have different accesses to the different functionalities of the project. And there is a part of our interface that has to do with assets, like loading assets, manipulating assets, inspecting them, and so on. And there's another thing that has to do with creating new stuff. So as when you are in the virtual space, you need to be able to create your own geometries. You need to be able to create your own things that you can add to your designs. And there is another MISC tool that has to do with how do you access the information and how this is becoming possible in an intuitive way. So I will quickly take you through the screenshots. Of course, there are some, let's say, kind of 2D-like screens that you need to provide your login credentials to log into Speckle. You need to have a player name and a nickname that you can be visible into the VR space. Of course, we have incorporated also an avatar selection because you need to somehow being represented in the 3D space. So there are some options there that you can use. And we are fully compatible also with a Ready Player Me service that you can easily use a photograph of yourself and have a kind of avatar based on this photograph. And then the idea here is to somehow make the distinction between the personal and the collective work sphere. So the idea is that in the personal work sphere, you are there to be able to draw some things on yourself. You are able to set up the scene of, let's say, set up the room where people will later join to discuss, and make sure that everything that is in there belongs only to you. And then we have the collective workspace, where this is where you share your material and you invite people to collaborate and discuss, and collaborate with you. So this is like the personal work sphere, and I will we have a main working table where things will eventually come, and I will explain you how. One other thing that we had to do was to decide how to provide access to all these interfaces that are necessary. So we have this RISC tool that gives you a number of options that you can use for doing all the activities that are necessary into this space. So all things come through at least the vast majority of the functionalities come through the RISC tool, a smartwatch kind of interface. This is for loading a project. I mean, you may consider, let's say, the process of loading a big project that has different versions, pretty much as you do in your software code. Given that we talk about architecture, it was decided to use this globe, and so as to be able to spin this differently, and based on the geolocation of where its construct is located, you should be able to download and bring all the necessary information there. Another thing that was important was to be able to bring things for materials for your from your file system. As I said, they need all the material that they need for their day-to-day job, like images, like PDFs that they can do. So as you can see, the RIS tool allows you access to, let's say, what we call a tablet, and there you can have a number of functionalities that you can use. So here, an image has been loaded, and an image and a PDF has been loaded, or a 3D model, and you can load them from your local disk, and then you can put it in whiteboards. This is the thing that's nice when you are in VR space. You can determine, let's say, the scale, the rotation, and distance, and so on. So it goes easily that you can bring up some photos from your local disk, and you can do this like a wall of informative images that may be necessary for the discussion. And then another thing that also goes with how you search things is this IDQS tool. So apart from your local file system, you can also look into all the information that is already in a Speckle stream, in Speckle. So here again, we have been experimenting this graph-based interface to see what is there, and also how to connect this interface with what lies on the table, so as to be able to click on a certain node and see where does this connect with the interface. So after having loading, let's say, the more simple stuff like the images and the PDFs and the TXT files and so on, then you can go to the actual 3D models. That is essentially the essence of such a project. Here we see a number of tabs there that they all correspond to the different, let's say, versions of the project. You may consider a project that starts with, let's say, having initial version with how the surroundings will be structured, having a next version with, let's say, some basic constructs, and then having another version with a more elaborated basic building, and so on, so to give you an understanding. All these have been somehow designed in, I don't know, Rhino or some other software tool, have been committed to Speckle, and here in Unreal we allow the user to draw, to browse this information and draw the information that he needs. And this is what happens when you click one of these tabs. We have this, what we call a multi-tool, where you see a different version of the object. So you can have many different this kind of tools into the space. You can have them side by side and compare them, or you can overlay them. And also this tool allows us to do the scaling and rotating of these models, or even to have some clipping planes to be able to interrogate it and have different perspectives on it. And also it's important to say here that this multi-tool, as we say, is able to load the models from different disciplines. So given that we have developed the connectors that I have talked earlier, here the Unreal connector is able to process the information that comes from Rhino, from Revit, and from SAP. You can see here that this model is very different from what are the other models. Still, they are able to accommodate for it. Now, apart from having this and inspecting them side by side, it's also deemed important to be able to snap them or pin them on the table, on the main working table. So there is an option to pin this, and this becomes is automatically transferred into the main table, and in the properly size and dimensions, and let's say the registration. It is important to be able to do this because essentially you want to discuss on how things incrementally build on each other, and you want to discuss changes and so on. And when you have done this, so by some scenario, when you have, let's say, set the scene for people to join, then you can invite your collaborators, and then you reach this kind of environment. This is, let's say, the more vivid picture of what we can offer. You can see here that people are collocated in the same environment, the same VR environment. They can interact with all the material. They can talk to each other, of course, using directed voice. and they can do a really good discussion of what they need and what is missing, what should be changed, and so on. And what is even more, when you do this, is that you are able, okay, before we go in this, we have also done a number of, let's say, auxiliary tools that are very, very typical into the domain of AEC, of architecture. One of them is the tracing paper that somehow allows you to, in VR, to be able to have a transparent view of what is underneath, and you can draw with the tools. You can draw and so as to convey your ideas or to convey some temporal, let's say, sketches. This is the tracing paper tool, and this is the clipping plane tool. So when you have models like this, you should be able to see inside them, or see when walls disappear. This is a very, very also basic functionality that was requested, and the clipping plane has been implemented using many different ways. I mean, this can be a cube that is transparent and is actually being able to cut the walls. Can also have a different shape if you like. And also clipping plane takes also place into these cubes. So there are many different, let's say, places where the clipping could take place. And of course, one other thing that I want to mention is that each and every one of these objects that are here can be manipulated. So there are different modes. We can change their scale, we can change their rotation, we can change the distance we have. All this can be manipulated to be placed in the proper, let's say, position inside this room to be further investigated. And another thing that we can support, as I said, is the design object. So apart from being able to load things from Speckle, we should be able to design some primitive geometries yourself. And a number of things have been supported, like doing some primitive stuff, like some squares or some cylinders. But we have also worked on some more advanced creation tools like Bezier and spline tools that you can define a number of spots, and then you can extrude these to become a very arbitrary shape that you can use in your drawings and in your, let's say, in the discussion about the model. These are more, let's say, a little bit more difficult to handle, but still most of the people working into this domain are familiar with using them. And another thing is that we should be able to leave comments. As we said, is that it's about collaboration. It's about being able to discuss things and give tasks, take tasks, and so on. So another thing has to do with commenting. So you can leave a comment in space or someone in a certain, let's say, geo position inside the model, or you can leave a comment associated with an object. And maybe here you can also add the name of the user that you would like, he would be needing his or her attention. It's also an important thing that because you can imagine that you maybe discuss something and maybe the involved person is not here, you should be able to leave a comment and in a sense assign a task to him or her, so she can later on join and deal with this task. And then after being in this collaboration space and now, let's say, facilitating a number of discussions or facilitating a number of factions, then you can actually move to inside the model. And here it is interface that we have this pin and a laser. When you actually, you can move this pin inside what is lying on the main table and identify the place that you want to be transported to. And by pressing the pin, you go inside the model. So this is, you can see that now you are in a one-to-one space with in one-to-one scale with respect to what you have been previously considering from as a GAD view. You can, let's say, this is the surrounding area, but you can also go inside and see certain stuff. And of course, all the different tools I'll also apply here. So here is the tracing paper where you can actually do the same stuff. Here is a combination of the tracing paper and the clipping plane. So you clip this wall, and then you can draw your idea of what could be used inside this building, or use some 3D object to place it. And of course, we have also trying to make best use. I mean, we are still in the process, but we can also make use of what can be offered by the VR technologies. One of them is lighting. So you can easily manipulate the lighting and see how, depending on the time of the day, how the shadow of this building will be, depending on the time of the day or the day of the month, or even the time of the year, the month of the year. These are all things that are become very much easy when you are in the VR space, and falls into the what we call the simulation. So when you do a design choice, when you decide to put a window, come to this very simplistic example, you want to see when the sun would come in, and this can give you a very much flexibility to see how this will feel. And some other functionalities that have done, like adding viewpoints, so you can, let's say, essentially these are bookmarks inside the physical space that you consider important, so you can later on visit as you go along. Loading 3D objects inside the physical space and putting them is also important. And apart from, so when you, I mean, these again are at the level of model viewer, discussing and so on, but at some point you need to be able to commit back what you have done. And first you need a way to select objects, like multiple objects, and then we have added this functionality of committing things back to Speckle. So everything that has been designed in Unreal, everything up together with what was already there, can be committed to Speckle. One important thing was to be able to add tags. So when you make a new object or when you load an object, you need to be able to tag it, or maybe you can, let's say, you can select multiple objects to give them a tag and group them in a sense by tagging them, and commit them back to Speckle. And what is, here is the commit to Speckle, so to the central database. And what is very much interesting, just coming back where we have started. So as you remember, it was probably Rhino or Revit that has initially committed the models that we have been inspecting inside the Unreal mode. And now we have been in Unreal mode, we have discussed in the VR space, we have, let's say, see the impact of our decisions. We have come to a conclusion. We have committed back the changes, and here is these are again visible in Rhino, and this is, I mean, this is a building that have created into Unreal and has been committed back to Speckle, and now it's easy for the connector. This is, let's say, how the Speckle connector looks, the interface of the Speckle connector for Rhino looks. We have been able to receive this and see in Rhino, so here you can do all the necessary changes, or do all the necessary inspections through such a tool. And this is also the case for Revit. And that will conclude my presentation, and I hope I have given you a very good understanding of how this would look. Sorry for having to speak for such. I don't know if someone else would like to. Someone would like to raise a question, or maybe I can stop sharing and see. Is anybody want to raise a question or ask some clarification? Maybe you can use also the chat if you want to express something. But yes, just to say that you have been seeing a prototype, although the project is nearly coming to an end. There are a lot of improvements that we will have in our mind to implement, and in order to, it has to do with, let's say, how people interact. It has been very essential and important that we have established the technology, and we have established the way to interconnect with different software tools and exchange information from typical AEC software tools like Rhino, Revit, SAP, with an immersed environment that is built in Unreal. This is what we call PrismArch VR. And so after having done this, we should be able to further invest of how do we interact with information inside the VR environment, how much information we can design in there, and benefit from the actual benefit from the fact that what we do in the VR space, in the immersive space, we have a more direct way of understanding its impact. We have a more direct way of understanding how this reflects on our actual design. And also we can benefit from the, let's say, huge amount of words that of the VR domain that has to do with the simulations and better understanding how things render, better understanding how this would look in a realistic environment and so on. I don't know if anybody else would like to add something or have any comment or... Okay, and I don't really know how many of you had the chance. I don't know if it has been a follow-up email for asking you to download the prototype. I don't know if anybody of you has done it, so we can try it out. Can you somehow indicate whether you would be interested in having a joint session or? Okay, I guess that will don't have maybe the time to do this because we have already been in an hour. Nevertheless, for those that have registered for this webinar, we have provided the latest version of the prototype, so you can try it yourself. It can be used either in as a VR or as in a desktop mode. And of course, you can always come back to us if there are questions or there is further interest that we can use, further interest that we can solicit. And that will be all. Thank you very much for everybody for joining, and don't hesitate to get back to us if there are questions or further interest, or you want to use, let's say, more of the outputs that we have produced in PrismArch.
Thank you.
Thank you very much.